I'll try to keep it interesting for you. I was quite pleased when Peter Jones put up the survey data on who is using Lustre and what people are doing with Lustre, because it really represents what we do as a company. We are not a systems vendor, we are a storage vendor. So I believe we probably have the widest set of customers in the Lustre industry, in the Lustre market. So yes, many of our customers use Lustre for AI and machine learning. Many of our customers use Lustre for research data. So Lustre for us isn't just a scratch file system. It is much more than that. It's really a versatile data platform for a broad set of applications. So we as a company, we focus on the high-performance computing market, meaning either scalable capacity or scalable performance, and Lustre really fits very well within that market. We have, in the last couple of years, increased our contributions to the Lustre ecosystem, and we have announced some investments over the next few years. So we are increasing our engineering team, we are hiring. The background here is that we do believe in a future for Lustre, and we do believe in a future for the Lustre ecosystem. And I'll go a bit over what we do with our customers with Lustre and what we call ExaScaler, which is our engineered, tested, people call it enterprise version of the Lustre file system. This is one example of a customer where we have done software work, not hardware. This is the Wuxi supercomputing center in China, where we have worked with them on a new approach that Lisi has been presenting at LUG for I/O forwarding with caching on the nodes. So this is a super large system, a very large Lustre file system with very specific challenges, meaning an extremely large number of compute nodes that do actually not run the Lustre client, but that do run simpler clients. So the work that we have been doing with this center is build a software approach with caching on the Lustre client for re-exporting to those compute nodes. Here is another example of mass storage with a customer that is running CFS. Here is another example. Population genomics is, for us, a very large market. This is a customer with 40, 50 petabytes of data for a whole set of applications, from genome pipeline to home directories, to application development, to release of data, all done with ExaScaler. Yesterday, Sebastian talked about multi-tenancy and isolation, which is another approach. So parallel file systems really haven't been about security and isolation or multi-tenancy. So here, this is a good example of a marriage between, on one side, dealing with performance needs, on the other side, dealing with functionality needs through isolation, multi-tenancy in a clinical genomics, research genomics environment. AI has been for us in the last 2-3 years really a main driver actually for our Lustre investments, and I'll talk a bit about that. We have a couple of customers today worldwide, in Japan, in the US, in Europe, who use ExaScaler for things like autonomous driving infrastructures. This is another example of a customer, small startup in the Bay Area, that is doing machine vision. In this case, it's an interesting application. It's called autonomous checkout in a supermarket. So you go into the store, you grab your stuff, and you check out autonomously. And all is done through machine vision. And the learning phase of that, data acquisition phase of that, is done through an ExaScaler file system with an addition of a fast cache. What we have seen in AI is that the feature set of ExaScaler and Lustre really works well with the application. We also use other parallel file systems. What we have found is that some of the feature sets within Lustre, like reasonably good mmap support or container support, data isolation, we talked before, good unique metadata operations, really make a difference in those environments compared to competing parallel file systems like GPFS, for example. We spent quite a bit of time with NVIDIA in the last couple of months to build a ExaScaler infrastructure for the NVIDIA DGX system, which essentially is just a GPU node with 8 GPUs. But the difference here is that in AI, most of the end users use containerized environments, not bare metal environments. So we have built an approach together with NVIDIA for a DGX1 system where the Lustre client essentially runs in the container. And we do a couple of things. So we have a mount point per container. We do container pinning so that the I/O doesn't go from CPU to CPU. We get really nice performance numbers, so we can drive 40 gigabytes per second out of a single DGX system, so a single x86 board just running a couple of containers. We see about 10, 11 gigabytes per second per container, which is essentially limited by the InfiniBand infrastructure. And we see about 100K IOPS per container. In a typical deep learning workload, very often we see customers doing I/O in the range of 64K, 128K randomly to random files, which is why this is an infrastructure that typically is all SSDs. So in those workloads, we see 5, 6 gigabytes per second of throughput from a shared file system, which is very, very different than taking your data, staging it on 50 GPU nodes on their local devices, and you see about the same performance. So here is kind of a new use world for ExaScaler and Lustre in a very different kind of environment that even from a system management perspective, has requirements that differ a bit from the classical HPC world. So many of these customers do not use job schedulers, they just use systems interactively, for example. Another area of work that we have been doing is caching in Lustre. So yes, we have built this thing called IME, which is a caching layer on top of a parallel file system infrastructure that essentially inherits the namespace of the parallel file system, and we have deployed a number of systems in a variety of environments from machine learning, oil and gas, weather and climate. Here is an example of a large customer in Japan. You may have seen the IO 500 results, which have an interesting way of using the IOR benchmark. So there is an easy case and there is a hard case, the hard case being I/O to shared files, and you can see that the IME extension to the Lustre file system, so it's still a Lustre file system, does extremely well on those hard cases compared to the easy cases. So the ratio of hard to easy is a factor of 50 to 60 compared to standard Lustre or GPFS or other types of caching infrastructures. And with just a couple of nodes that have SSDs, we can now build a file system that has a throughput performance that is 10x, 20x of the backend Lustre file system, but is still a Lustre file system in itself since it inherits the namespace of the Lustre file system. A couple of years ago at LUG, I think it was 6 years ago now, we did a small presentation together with ANU. Daniel Rothwell is here on monitoring using Grafana infrastructure with a time series database in the backend. That is today, I think, the standard approach for monitoring. We have spent a lot of time in the last year on perfecting that approach, so that is available as part of the ExaScaler package today with many additional features. And I appreciate all of the collaboration from customers to really make this a nice and interesting monitoring environment. In terms of development focus, we have started with a couple of projects a couple of years ago. Project Quota, for example, Many of these projects came as requirements from end users as opposed to developers sitting in a room dreaming something up. So our focus has been around usability, around RAS features, around performance, but also around security, as we have talked about. We have expanded that in 2017 with a couple of new projects. So fast metadata scanning is something we have looked at extensively. Persistent client cache, I mentioned earlier, and then support for containerized infrastructures as well as CFS support. And for 2018, here is a list of our priority projects. So we have been working on a new policy engine design that is tied into the metadata machinery. We have done a lot of work on metadata performance recently. So now we can build a metadata server that does almost 200,000 creates. We have a couple of more presentations today on data and metadata features. I think we have all been waiting for a long time. And then, as I mentioned, we have done quite a bit of work around security, containerized Lustre. And it turns out that those things are interesting to customers in cloud environments, in AI environments. And then a new focus is really around very large, scalable Lustre file systems for almost archive-like environments where customers have not petabytes of data, but tens or hundreds of petabytes of data. And those requirements do drive the demand for things like end-to-end T10 PI, potentially also a CFS backend. Now, we are a systems company, so we sell systems or appliances. Even so, there may no such thing as a Lustre appliance. It is still a Lustre file system. We focus on usability. We focus a lot on optimizing systems for flash. We do focus, as I mentioned, on things like security and security models. And we do now also support CFS. So as a company, our product portfolio really has evolved in the last couple of years from enterprise storage systems to platforms to software-defined storage appliances. So we are no more the DDN of 10 years ago where we sold you a big, expensive RAID controller. We do a variety of things that go all the way from almost commodity platforms to pure storage software. From a systems perspective, we do still build very large systems that we call scale-up systems, so large building blocks like here, a one-rack building block, a single system, 70 gigabytes a second, 9 petabytes, two systems that use many small modular building blocks that would go up to 800 gigabytes per second with NVMe, and about 10 million IOPS in a single rack. So this is the product portfolio all the way from small systems, so the smallest building block, which is a 2U integrated Lustre system with metadata servers and OSS servers virtualized in a 2U box, all the way to the large building block here is an 18K system. I'll briefly talk about that in a moment, to modular building blocks that scale across many racks, either for drives or NVMe devices. So enterprise systems, our main platform is still the 14K platform, 40 gigabyte per second building block, about 1 million IOPS. We will upgrade that system in the next couple of months to an 18K system with about 70 gigabytes per second, 8 enclosures per building block, and a bit more IOPS, NVMe support, et cetera, et cetera. These systems use a virtualization stack, so there is a RAID backend that ties into a virtual machine infrastructure that today is a standardized virtual machine infrastructure with VirtIO SCSI in the backend. So it's almost a bit like a hyper-converged environment. And on top of that VirtIO SCSI stack, we essentially build the various services, whether these are MDS services or OSS services. We are introducing a new set of products this year, so modular systems. So here is a 2U NVMe building block. Here is a 4 to 12U drive-centric building block. On the left side, this is the system going from 20 to 40 gigabytes per second. Again, available in different versions with virtualized services. This is a building block going up to about 20 gigabytes per second with 40 to 260 hard drives in a modular fashion. Both of these building blocks are available either with LDiskFS and the SFA OS or with CFS. So you can buy these hardware building blocks either with a CFS RAID stack or an LDiskFS SFA RAID stack. There are differences, and I want to briefly discuss that. Here on the left side, this would be sort of our baseline building block with a metadata SSU and the data SSU. With LDiskFS, we see a bit higher throughput. We see a bit higher metadata, actually quite a bit higher metadata performance. We do see a lot higher IOPS performance, which is important for certain workloads. A boot and failover are significantly faster. Usable capacity is around 79%, depends a bit on the RAID configuration. If I compare that with CFS, yes, throughput is a bit lower, metadata performance is lower, IOPS performance is quite a bit lower depending on configuration. Boot and failover is slower. Usable capacity is a bit lower. There is the CFS overhead, so it's about 6-7% of usable capacity. But there is a feature set with CFS around data management that for certain customers is, of course, interesting. We do provide a system management stack for the SCS services with these CFS appliances. We do limit them today to around 80 to 100 devices per processing unit. With the SFA stack, we go up to about 400 devices per processing unit, which is really what makes the SFA stack unique. So it is a very efficient RAID stack where I can put a lot of devices behind a single processing unit. And the processing unit here, a single CPU, runs both the RAID stack and the OSS services. All of these platforms are available as all-flash systems. So we see a trend towards all-flash systems slowly in the high-performance computing market, much, much faster in the AI market because, as I said earlier, the AI workloads are random read to random file workloads. So we see a lot of interest in Lustre file systems built on flash. So we have multiple offerings here, from a 2U offering, all NVMe, to the high-end 18K offering, up to 70 gigabytes per second out of a 4U box. So give or take, this is the product offering that we have. As I said, being probably the largest HPC vendor according to the various services, we do continue our investments in the Lustre file system. Even so, we also do other things. I talked about the IME project, and we are really taking that to a next level in the next couple of years. But we do see a strong future for Lustre beyond just the standard HPC market. So the future for Lustre for us really means expanding the market for the Lustre file system, not just ExaScale and very large HPC systems, but AI, deep learning, enterprise analytics, multi-tenancy for cloud environments, data isolation, and Lustre for Scalable archive, which is kind of a new area. We see those markets requiring new features. Data on metadata, scalable metadata is an important new feature for all markets that do things like data analysis. Better support for flash and NVMe is an important area for the DI market. And then in general, enhanced protocol support with export to NFS, CIFS, S3, or Swift is an area, I think, where there is still work required. And finally, those new markets also come with additional requirements for robustness, for availability, and for usability. So for us, this means continuing investments in test automation, which are really crucial, investments in health monitoring, and we have a couple of ideas here, as well as improved logging and failure reporting. So these are the things that we want to do in the next couple of years. We will not do them alone. We will need the entire Lustre ecosystem to go along with us in this journey to expand the market for Lustre beyond just high-end HPC. Thank you.
Do we have any questions for Robert?
Mentioned the AI/ML performance numbers, so could you please tell a little bit more about the workloads that you use to get those numbers? The AI/ML performance numbers that you mentioned in those slides.
Right.
What workloads did you use to measure those numbers?
So mostly synthetic tests that mimic. So typically, any project we do comes with an acceptance testing. And AI customers have, they're very often their own applications that they want to test, or have a special benchmark program that was written for a procurement. And these are just data that mimic those workloads. So it's mostly random read to random file workloads, but synthetic workloads, not. I didn't show any customer data here.